Okay, I believe it's time to start. Good morning, everyone. Welcome to what I believe is the 9th lecture. Today I'm going to talk about a little bit about unit testing. I know you had, those of you who took the project course had lecturing that last year, or was it this spring? But I wanted to be more concrete and show you a little bit of code and help you out a little bit with assignment 3, just to give you some reference. And then I'm going to go into refactoring and show you some code on that as well, and just to give you a realization how bad things can be. So I'm going to show you a project that was developed at the university, not by me, but in which the code is really bad. And I actually had a master thesis project on refactoring this code. And then after that we had something that worked, and then after that again we did everything in Django. So it's been going through 3 different alterations along the way. So I'm going to show you that a little bit as well, just to get an impression of, or just an idea of what to do, etc. Can you hear me in Celestial? Just thumbs up, or? Yep, good. Okay, let's start off with a little bit of JUnit. So this is kind of my splash page, just to show you what it looks like. So we have a class here called message equal, nothing strange about it. So we basically just have a message, and then we can print that message. Very, very simple. And JUnit or tests, it basically, well, you have all the imports as normal, and this parameter here is called an annotation, and it is important. Like when you have when you write in Java, you can have these params which add to the documentation of the Java does, right? But in JUnit and in testing, the act test means that whatever comes next, the method afterwards is being run. So it doesn't actually matter what this one is called. As long as it's a function, it's being run, it's being used, so to speak, and that is part of the JUnit test. And then we have an assert. An assert basically checks if something is correct. So it's basically, in this case, it's assert equal. It means it runs the equal method on an object, and it compares, in this case, this message, this here, hello world, against message equal.print message. So basically here, the outcome of that. And in this case, we know that it's going to be true, so it's going to pass. Now, if we did something weird here in this print message, it's going to fail, and we're going to get it captured. So that is basically how the unit works, in very simple terms. I'm just going to show you a little bit about the differences, because JUnit 5 is out now, but in the assignment we use JUnit 4. It doesn't really matter that much. There are some differences. So these annotations, there are a bunch of them. I wanted to show you this as well, just so you can see what kind of annotations there are. Of course, there's the test one, which is whenever you want to run a test. There is before class, which is basically if you want to initialize some variables or something like that, you use that. And that method or function is being run before any other test. You can do after class if you want to close the reader or close something. You can do before and after, it's being run every time before a test. So if you want to reset something, or you want to set something to null or something like that, you can use before each test. And after, if you want to do something after every test, you can do that. Of course, you can ignore, and then you can categorize them or tag them. So that is basically different annotations. Not too difficult once you just figure it out. and you have some limited options to do this. There are some special cases if you want to test exceptions, etc. There are some other cases as well where you can read up on. The documentation is available on the assignment webpage. Then looking at the assertions, again there are some few slight differences, but most of these are the same. So you can assert true, assert same, null, not same, not equal, not null, false, assert equals, and then assert array equals. So those are basically just Boolean tests, kind of. Just looking at how you make them fail. So assert true, of course, if you have some conditional statement there, if it fails if it's false, basically. Assert false, then it fails if it's true, equal, etc. One thing that could be noted here, assert same uses the equals equals operator to compare, while the assert equals uses the dot equals. So that is some slight difference. Or both of these then. And all of these asserts come with either you can have one parameter in this case or two in these, or you can add a parameter as an error message. You can do like assert null, the error message that should be printed if it returns false, that it doesn't work, it doesn't pass this test. So this is printed then just to have some clarification on what's gone wrong. Before I go into to show you some code, I'm just going to go some basics, some recommendations from him. You can add a lot of tests in one test function. Problem is that if something breaks, it kind of exits that function. And I'll show you what I mean when I get to the code later on. But that means you might actually miss out on some of the tests. It's better to create lots of small tests rather than one big test that does several different things. Which means, of course, you're going to end up with lots of functions like these. Lots of these tests. As I said, you could add lots of assert equals in this one. But if the first one breaks, you won't go through that one. Oops. So there's a few small ones. And if you have exceptions, there's this expected outcome, and I'll show you what that looks like in a moment. But you can try to avoid these try and catch statements, or let your unit test them. I'll show you how that works as well in the code later on. Also, if you have dependencies in order, like if running test A before B makes a difference, then you might want to look at the code and see if something's been. So this is what it looks like if you want to test an exception. So basically, we have this annotation of the test, but this one can also take some parameters. In this case, expected, and then the exception that you are looking for. So in this case, array index out of bounds exception dot pass. You can do IO exception dot pass, etc. So basically, if your function, you can actually force it to go into an exception, and instead of doing, you still need to catch it or throw it in your method or function. I'll show you how that looks like as well in the code. But basically, this one, if you get the index out of bounds exception, it will actually pass this test because you are forcing it. This should be an exception. So you're testing the exception that it actually gives an exception. Good to know. So, any questions so far? Otherwise, we'll get into some kind of coding. I prepared some because I didn't want to write everything from scratch. So one of the questions I would like to ask when you look at the code is whether it's designed to be testable. We use that as methods, right? It's a design quality or quality attribute. Is it testable? So let's have a look, and I'll get back to that question in a moment. Lecture. So you see that? Right. So this is the basic class that I made. What it does is basically calculate whether you are allowed to buy alcohol, because that was a very simple scenario that I thought. The rules are as such, or the requirements. People younger than 18 may not buy alcohol. People between 18 and 20 may buy alcohol at the supermarket, and that's maximum 3.5%, or they may buy alcohol at restaurants and then any alcohol. And then people 20 years and above and older may buy alcohol at Systembolaget, and of course restaurants as well. So those are my simple rules. What this file does is basically takes an argument for a file name and sends that to the read from file method. This read from file basically just opens the file on the screen, etc. It throws an IO exception, by the way. It's good to know. It opens the file, it reads from the file. The first file is, the first line is just a comment kind of. So it's a CSV file, comment separated values, I think it stands for. In this case, it's semicolon. And then it checks whether it has two parameters. Otherwise, it has, correct input file. And I basically just, first field is the name, second one is age, and then I call this buy alcohol method basically to get whether they are allowed to buy alcohol, and this is the result. Any questions about the code so far? It's very simple, right? Okay, so I will run this at first. I made some scripts because looking how it runs and stuff isn't that interesting. So basically, I have two input files, one that is working, which is basically Eric, 15, may not buy alcohol. John, 19, may buy alcohol at the supermarket and at restaurants. Linda, 29, may buy alcohol at the Systembolaget. Then we have a non-working code, which is I can show you what that looks like. Error data. Basically, John has no age, so that there's not what are proper code method file. So, well, 15 may not buy alcohol, and then it's correct input file. So, very simple. Looking at creating tests for this then. I've made a skeleton file here, just to cover all the important stuff like that. So the first I want to do is create an instance of my lecture, right? Because I created my code in such a way, so I need to have an instance of it. These are not static. So I will do before class. Actually, that means I need to before class. And I will do public init. Since this is not my regular keyboard, I might have to struggle a bit with I have different keyboard mappings between my desktop keyboard and this one. Okay, what I want to do is basically do test equals new lecture. Okay, now we have initialized this instance. Should have done that up there, I suppose, but I just wanted to show you. Let's make a test to begin with. Let's do a test for someone who's below 18 years of age. Okay, so again, we use the test annotation, and then what we want to do is basically test this method, right? Because this one has an age, we know what the outcome should be. What was the name again? It was by alcohol, okay. Search equals, that's a good start. 18, comma, by alcohol. Let's do 16 years of age, right? So that should be true. Let's see if I done this correctly. I might not have. Let's see. Coding on the fly is always a bit. And I've done a unit test script as well. Init should be static. I will choose. Oh, okay. So it's because I changed something that I shouldn't have, that I didn't test. Let's go back to that. So before class, use a static variable or static functions. Who knew? I wonder if that works now. Let's see. We can't go more than wrong, otherwise I know what to fix. Of course. Let's do this the way I did it before then. Before, and then I just do for. You can read up on the documentation of this later. Do it properly. Oops. Okay, expected. Speak again. It's the Murphy's Law thing. Right, of course. This is why coding live is always a bit tricky. Because you don't think properly. Well, this is kind of a good example of simple mistakes that could happen. Because the outcome is of course not 18, because I forgot the outcome should be named off by alcohol, right? Because we return a string. And actually I could have seen this in the outcome here. Expected 18, but named off by alcohol was the outcome. So I actually saw that in the error message, which is good information. So it can actually help you figure out what you did wrong. Now, this test should pass. And this is another reason why it's nice to have these scripts, because you end up running tests a lot, having to like add the code all the time. Okay, so this test passes now, right? Now, since I also do the whole code coverage report here, I will actually show you what that looks like as well. Of course, I did post file. So right now I have my LTU package. Let's see if I can increase the size of this. Okay, so I have done some test coverage here on by alcohol. I have 83. Well, I have missed some branches, obviously, because I only tested below something. And I have I covered 1 out of 4 branches. Let me increase the size of this as well. So you can actually go in here and check. Okay, I've done this one. So I covered below 18 already, but I have not covered, between 18 and 20 and so on. So it's handy to check what you've been covering and so on. Now we'll see in a moment that you won't be able to get all the branches, and I'll explain in a moment why. All right, let's add some tests. Test public void 18 and up to 30 very descriptive tests. Search equals that's what the message should be. Made alcohol. And let's do 19 now, right? So that should also pass. And let's check it just to make sure. Tested, but was 19. Whoops. Did I mess things up again? Oh. Of course, test of by alcohol. If I found it quickly. This should be correct then. Yes, two tests pass. I will just, I have two things more I would like to show you. Well, first of all, I'm gonna do, I'm gonna introduce a mistake. And I will do this by simply removing this here. So it's now above 18 rather than 18 and above. Which, if I show you this now, I will still pass this test because my age is 19, so obviously I'm above. Yeah, I still pass. So what I'd like to illustrate with this is the importance of testing all the limits. So in this case, I only tested 19, right? But the age limit is from 18 and up. So you please, when you do your test, do all these limit values as well, because this one should fail. Now try for someone who's 18. And it fails, right? Okay. Let's fix that back. So that was just to illustrate an important point that you might have use for it. I will just do the final test as well. I'll repeat and I'll put it in same here. Equals. I will do the made by alcohol Systembolaget. And let's do 23. Okay, now we should have covered all the bases, right? We have below 18, we have someone who's 18 and above, and we have someone who's above 20, right? And I will illustrate one more point here. I forgot the semicolon. Okay, it passed both tests. I only have 2 tests now because I made 1 test with 2 specs in it. But for now, that doesn't really matter. Now, if we reload this page and look at the bioalcohol, we see we have 100% test coverage here, it says. But we have missed branches. Why is that? Let's go in and check. Now, it says that we've covered, I have missed 1 out of 4 branches. I still have 100% test coverage. Why is that? Well, in this case, of course, it's going to do, it doesn't do proper lace evaluation for these things. It actually does check if first parameter is true, second true, false. I'm not sure if it does false and true and false and false, because it might actually be clever enough. But in this case, H cannot be both true and false because it's the same variable, right? So that's, of course, we want to have full branch coverage. If these were different variables, H1 and H2, we could have made sure to cover all the branches because they could have taken different values. But now it's the same variables, so of course that's not going to be possible. And JUnit is not clever enough to understand this. Just a note, so don't be too worried about the missed branches in some cases. But still have this 100% test coverage in this case. Oops. Yeah, 100% coverage. Okay, and one final thing I would like to show you, and that is just to test its exception that we have in the code. So in this lecture, we have this throws an exception if we don't have a proper file name. The file does not exist. So let's test that. And now, since I showed everything else, I can show you my code. Okay, so what I do is I create a test. I do this expected. In this case, it's an IO exception. Note here that I actually need to either catch it or throw it. In this case, I do invalid file throws IO exception, because otherwise, I'll show you without it. Show you what happens. I think actually it breaks in the compiler. Okay, so here it's a basic compiler error. IO exception must be caught or declared. So bringing that back again. Now I should have 3 tests and they should all pass because I added an invalid file. I don't have a file like that. Okay, that was very basic testing. Any questions on the basics of JUnit? Good. Was it helpful? Did you get some understanding of Assembly 3? Let's go back to Oh, the last question. Is this designed for testability? Let's just analyze that quickly. So I will show you now that I have not really, even with this new exception test, I haven't really tested this read from file. It says still 100% missed instructions. It's still completely red. I did test this exception, but I have not tested anything in here. I will increase the size here so you can see what I mean. And the problem is that I can only really test some return, some outcome, right? And when we look at this code, and this red thing is annoying, let's go back to the code instead. So I can only really test the output, the returns. Assert true, assert equals, assert null, and all those things. And the problem is this one does not follow the good programming metrics, because this one reads from a file and it prints stuff and it calls this, it actually does the calculation as well. So if you remember the whole metrics about primitiveness, one function should only do one thing. Well, this one doesn't. This one does several things. And that also means that it's not so easy to test. I cannot properly test this input file part here, for instance. Like, because I can test whether I can read a file, or if I cannot read the file, if the file is invalid, because I have an output, an exception. I could test with input data and look at the output. I could see like the printout. I could check. Actually, no, because this one prints in the terminal, so it's not the return value either. So I cannot test that either. If I instead had something like this, a string, and rather than doing print here, system out, I would do a return, whatever. Return the string. If I had something like that, I could actually feed it an input file. I could test if the output was correct. But that would be basically the same thing as testing this dialcohol method separately. What I would test additionally would be this whole name plus age thing, would be the only thing I would add to that. However, I would also be able to, if I, for instance, do, rather than doing system out here, I could do return corrupt file. Then I could test for that as well. I could test this bad input file will return a corrupt file. So that would be a way to make this more testable. But in general, this code is not designed to be highly testable. For the quality attribute testability, it's not designed to be highly testable, because this one does not, it's not primitive. It does not only do one thing, it does three things. It reads from the file, it checks whether the file is correct. That is fine, you could put that in the same method because it's, you know, in the same category. But then it also does all the printing and all the, like, you know, yeah, it does the checks and everything. So maybe that should be in a separate method then, if you want to do it testable. Does that make sense? So now I've illustrated the quality attribute a little bit to make you, yeah, hopefully that helps. Okay, now we go back to, actually I will do some undo. Otherwise, I will forget this to next game and I will give the code. All right. So it's time for design for testability. No, metrics. Well, in this case, primitiveness was one thing. Same would go with classes. Cohesion would be more difficult to test if you didn't have high cohesion. Coupling as well would also reflect the testability of things. But that is something we talked about when we talked about testability. Okay, on to refactoring. I'm thinking maybe we should actually have a break now, and then we'll do the refactoring. And actually, I took your input, so I have a video for funny video. I've listened. So you feel free to take a break or whatever. I will play the video.
Hallberg. Must be the new trainee? Yeah, hi. Yeah, welcome. Look, I'm supposed to show you the ropes, I guess, so welcome. Internet Help Desk. It's a tough gig. Yeah. No, I figure you got 4 basic essential services in our society. You got your police, your fire, your ambulance, Internet Help Desk. You know, air traffic controllers claim they have the most stressful job. Ha! But I'll tell you, man, there is nothing that beats the adrenaline buzz of configuring some idiot's ADSL modem, even though he's running Windows 3.1 on a 386 with 4 megs of RAM, man. Just a second. Thank you for calling the Internet Help Desk. One of our trained technicians will be with you shortly. Please hold. Okay, so that's the first thing. The hold button is your best friend, okay? Always put the customer on hold right off the bat. Shows them who's boss. Thank you for holding. Your call is very important to us. Please hold. Take some of the fight out of them, you know? Which is important, because when they start telling you they don't know how to use a mouse or that they've been putting their coffee cup in their CD-ROM tray, and they start to realize what an idiot they are going to be venting all over you, my friend. But don't worry, I'm here. I'm a vet. I'm a pro. Hell, I've been here 8 months. Which, you know, in internet time is about 25 years. Okay, thank you for holding. My name's Wes. How can I help you? You can't get your email. Ooh, that does sound serious. Okay, well, can you be more specific? You can't. Okay, please hold. Thanks for holding. Okay, I'm going to need to find out if you're running Microsoft Outlook Express or Netscape Communicator. No, you don't. Okay, well, look in the top right corner of your screen. Do you see a big blue E or a big green N? Big black nothing. Okay. Well, I'm really sorry. That's totally my fault. Okay, what you're going to need to do, now listen to me very carefully. You're going to have to turn your computer on. Yeah. Okay. Okay, yeah, I'll wait. Guy's got 10,000 times the power of the computer we use to land on the moon, and he needs me to turn it on. Okay, good. You got it all booted up? No, sir, please stop kicking it. No, is it turned on? Good, great, okay. Now, what I'm going to need you to do is I'm going to need you to read me from the big TV part. You're going to need to read me the name of the little picture that you double-click on to get your email normally. Microsoft Outlook. Okay, so Outlook Express or Outlook Express. Okay, great. Go ahead and double-click on that. All right, good. Okay, now I need you to go up to your tool bar. Up at the top, there's File, Edit, View, blah, 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 Tools, okay? Click up there, bring it down, click on Accounts, okay? Then when the window comes up, click on the Mail tab, click on the blue text, click on No, Tools. Tools. Tools, sir. Microsoft Office, no, you're not running Office, sir. No, you've run the wrong program. No, it's my fault entirely. Don't worry about it. Okay, good. Just no illegal instruction. Well, I'm sorry, your copy of Office must be proof, sir. No, you haven't broken any laws. It's an illegal instruction. It's a computer. No, sir, please stop crying. Do not unplug it. Do not unplug. Okay, well, let's just plug it back in there. Good. Okay, excellent. All right, you go ahead and just let it start up, and I'll be right back. Okay. We got a serious 12 o'clock flasher here. Okay, you know what that means? Every appliance in his house is always flashing 12. There's no way to get a 12 o'clock flasher online, okay? It cannot be done. I've seen guys eat their own headsets trying. It can't be done. And I've got to go to plan B. Hi there, sir. I was just wondering, do you have a child in the house? You do? Great. Good. And how old is she? 9. Excellent. Could I talk to her for just a second? Great. Thanks. Hi there. Hi, who am I talking to? Well, hi, Beth. What grade are you in? 4. Wow, that's great. Who do you like better? You like the Spice Girls or you like the Britney Spears? Oh, yeah, I guess they are a little 20th century. Okay, listen, Beth, here's the thing, okay? Your daddy really needs to get his Outlook Express configured to use the third-party dialer instead of LAN or, whatever it's set to. Yeah. Could you configure that? Thanks. Okay, and check out his SMTP preferences. I think they might be poops. Okay, thanks, Beth. Oh, and Beth, look, if I were you, the next time your daddy tells you his computer isn't working, tell him it's broken, okay? And tell him to give it to you to play with, and send him out to buy an iMac, okay? It's a computer especially built for for mommies and daddies, okay? All right, Beth. Okay, we'll see ya. No, I don't want to talk to him. Thanks. Okay, bye.
That was our 5-minute break. Okay, refactoring. I need to see if I still share. Oh, yes, I do still share. And I need to lower the volume thing. Okay. So refactoring. It's about, improving the code. There's a statement. Fowler is one of the people who leads this area, or one of the people who's quite prominent in this area. So any fool can write code that a computer can understand. Good programmers write code that humans can understand. So a lot of these quality attributes we talked about, a lot of the design patterns you might have looked at, they deal with creating readable code, human readable code. And it's something we strive for, to recognize code, to understand the structure of code, etc. Because it does help us with a lot of different things, like modifiability and understanding when there are bugs, and basically just making our work more efficient. So the structure of this here, I'll just go through some basic theory. I'll give you an example. I'll show you some code, and then conclude this. There are a number of people who have been working in this area. Lehman is one of them, and his law is about this whole continuous change or program evolution. So the law of continuing change. A program that is used in reality must change or become progressively less useful. And then we have the law of increasing complexity. As the program evolves, it becomes more complex. This will continue until work is done to maintain or reduce the complexity. So these make sense, right? It's basically, if you want to keep the program relevant, you continue changing it. You may add features, you may improve some things, you may fix bugs, etc. And as you add things, as you improve things, typically things become more complex unless you try to re-engineer, try to fix things, try to improve the code quality, basically. So what is the re-engineering then? Well, it's understanding and improving the system. So it happens in like typically 3 steps. We examine the current code. We analyze, what can be improved. What is the purpose of the code? What is the outcome of the code? And what is the desired outcome of the code? And then when we know what the desired outcome is, when we know what the bottlenecks are, when we know what the bugs are, we alter the code to fix it, quite simply. And re-engineering, it should not change the functionality. It should keep the functionality but improve the code quality. And you can do that in many different ways. There are 3 basic steps. So you have the reverse engineering part, and that is basically what you're doing in assignment 1. You try to understand the code, right? You try to figure out the current structure, the current architecture. You try to create the documentation, so to speak, from something that may not be well documented. So, I know some of you have some documentation already, but that is the whole, trying to understand how everything works. Then you have the restructuring with refactoring, where you start altering things, when you start improving, you start reusing parts of the code, reusing modules, you reduce the bottlenecks, you make the code more readable, you start using design patterns and all those things. Then have forward engineering. That is typically the way development happens, and that is when you start from something abstract like a UML diagram and you start developing from those definitions. So this may not be so much as re-engineering as it is going from specification to code. However, it is part of re-engineering or refactoring when you have to do a really big refactoring part of the process. And I'll show you this in a moment. So we want to make the system better, more maintainable, easier to understand, better performance, etc. And we want to be able to increase the capability of the system, like coping with new software, new operating systems, new hardware, etc. So starting with step one, reverse engineering. Well, you have some idea of that already since deadline for assignment 1 is today, right? So you've done part of this, you analyze the components, how they relate to each other, create a description of the system, whether that is in UML or something else, where you try to describe how everything works. And of course, the more complex it is, the harder it is to reverse engineer. So the refactoring part is basically keeping the functionality, not changing the behavior of things. So just as a brief example, we can do this math problem here. So x minus 1 times x plus 1. We know that this happened to be x squared minus 1. That's the result of it. So both of these are exactly the same, but they look different. This is less text. I don't know if this is more clear, but it's different. So that is the way you think when you do re-engineering. You keep the behavior. So it's not the same as rewriting. You can rewrite the code and just keep the intent of things. I'll get into that when I show you the code. So in the forward engineering, basically that is the abstract thing going into physical implementation. So we have different levels, of course, that we can do re-engineering. Source code level, we might change the structure, we might improve algorithms to make them more efficient, or make it more flexible or more modifiable or something like that. We might do language porting to go from C to Java or whatever. That is, or from one system to another, porting between I don't know, PC and Mac or Xbox and PS4 or whatever. So there are lots of purposes or reasons why you want to do some re-engineering and refactoring. And then when we talked about design patterns and we talked about quality attributes, this whole portability, being able to keep some part of the code that acts the same and then just vary the different parts that are different. A lot of mobile application has very common behavior between like iPhone and Android phones, where only the interface might vary depending on how much native functionality they use. And you can update on functionality level. You can update the class if it's object-oriented. You can do interface changes, names and stuff like that to make it easy to understand, easy to read, and easy to structure. And you can do it on architectural level. What components are you using? Interactions, reuse, and so on. Improve the modules and packages and stuff like that. How everything fits together to make it easier to use your code and easier to understand. So we've talked about these three: the reverse engineering, the refactoring, and then the forward engineering. But if it's impossible to understand what the code is, there might be cases where the code is just so bad that it's very, very difficult to actually refactor it. And if you don't believe me that might be the case, I will show you code in a moment that will make you believe. So what do we do? Is it possible to abstract this further? Well, maybe we need to involve this intentions level. What was the intention of the program? What were the initial requirements that the program has been built upon? What is the system supposed to do? And what you can do is kind of like you can refactor or recreate something just to reach the same functionality, kind of like a black box system. You know what the outcome should be, and you have no idea what the actual code, how it works. And you can recreate this. So it's kind of a new architecture in that sense. So basically what we're doing here, or what we're thinking about is So you have the reverse engineering. You try to analyze the intention. You analyze the architecture as it is now. Is there some parts you can reuse? You analyze the functions. What are the requirements, functional requirements? That's the code I did with, and you look at the code. And what you try to do basically is do forward engineering. What you do here during the reverse engineering part if you're doing a design run, you create the design documents. Like these are the functions that the software should achieve or have. And then that becomes a foundation for a new specification. And from that specification, we can do forward engineering, basically regular development, create a new architecture, create a new design, basically. So some problems that we can encounter then on architecture level when we try to re-engineer or create reverse engineer. Of course, there might not be sufficient documentation. The layering might be really poor and very difficult to understand the modules, etc. There might be a lot of duplicated code, so they haven't done proper code reuse, duplicated functionality. All those things make the code very difficult to read, right? And also not so flexible, and if you want to change some part, you need to change it in several places. So how do we do refactoring? Well, do it in steps. Doing it all from scratch will probably end up doing everything, every part of it might actually get you into a lot of problems where nothing works, right? So reuse knowledge. You have a lot of tools at your disposal. You have design parents, which you can reuse. You have quality attributes where you can reuse some functionality. You have frameworks, middleware, and maybe third-party software that you can build upon. All those things are tools that you have at your disposal, so you can make sure that, okay, this framework will actually solve all those applications for me. I don't need to do that myself. It's someone else already did it. Or there might be some other module at the company that you can use that achieves some of the functionality, so you don't need to do everything from scratch. And our idea, or the idea with refactoring then is, of course, to increase cohesion, decrease coupling, modularize the system parts, all those things, decrease the class size, better names for things. So these are all the metrics that we've gone through in both this course and the project course, right? So these should be familiar to you by now. And they return over and over again because they're important. They affect the way you do coding. And of course, you can do on different levels as well. And when I went through the design patterns from those video lectures, I did describe them on like structural, behavioral, creational patterns, and then we have architectural patterns as well. So those 4 categories I used. There are more categories as well. And you can do them on different levels. And there is a nice webpage that Paul has put together that's called refactoring.com, where you can find a lot of tips and tricks for this. You can go in and look at. Some of them are very basic because not everything needs to be complex. So some of them you might be, oh, well, I already do that or whatever. And when you start using frameworks, suddenly you bind yourself to like kind of an architecture or the way of doing things. But there are terminologies, so there are hotspots, and they are areas where you might, as a developer, might do changes. And there are frozen spots. Now, the reason why I bring these up is because what you want to do is keep the hotspot as simple as possible, right? That's where you, as a developer, have to go in and make changes. That's the code you have to understand. The frozen spots, the framework, how the entire authentication works in the back end or whatever. If you're using a framework, you don't really care, do you? All you need to care about is the documentation, the API. And how they implement it is not so important. Depends on if you have some requirements on you that you need to ensure, like security requirements. You need to make sure everything is consistent. You might have to go into the framework and stuff. But often there is documentation for the framework that will tell you these things. So it doesn't matter if the frozen spot here is a lot larger than you had before, apart from performance issues, of course, because you will never look at that code. It's modules. It's the framework that exists that you can build your code upon. What you want to achieve is hotspots that for your developers are readable, that are well structured, etc. So I'm going to go into this real life example. And as I said, this is code that was originally generated at university, not by me. I have to tell you, and I had a master student that did re-engineering on this, and he wrote a master's thesis on it, and I based part of my slides. These slides are based on that work as well. So I was very happy with the student, by the way. He did a great job and did a great thesis. He lives in Dalarna, he lives in Dalarna at the moment, and I wasn't able to bring him here to give it extra for you. So, well, basically this thesis was the whole software engineering thesis. It was about re-engineering and learning about re-engineering, refactoring, and software engineering metrics, and basically everything that's in this course. It was basically showing that in practice. That was the thesis. So understand, update, expand. And the whole purpose of refactoring this code was to increase maintainability and understandability of the code. Because we realized it was really bad. So this software called Memolane is life logging software. Basically, it's used for people with dementia. They wear a camera, and that camera captures their daily activities. And at the end of the day, you can see between this, in the morning you were cooking, and then you went to the park and so on. And it's to help them remember what kind of activities they've done throughout the day. So it was web application, PHP was the main program, PHP and JavaScript. The activities were stored with pictures, and the pictures were also analyzed and grouped into activities based on some GPS and time factors, mostly. So they were clustered into activities based on activity recognition. And yeah, that's the camera, and it looks kind of like this. Now, this is very basic, but you basically have you can set the place, you can set the persons involved with activity, you have a representative image, you have a subject and a description for the activity, and that's basically just to summarize it. And then you have the different pictures, so you can select which ones to keep and which ones to throw away. Yeah, so the activity recognition basically just sorted the pictures into finishing work in the office, at the bus stop, having dinner with your one, and you try to annotate it with people as well as with the activity. Just to do some clustering, just to help them sort out their day. So it's not just one activity with 300 pictures. I think they generated about between 300 and 1,000 pictures per day, because they took pictures every other minute or so. But also took pictures automatically when you moved a lot, or when the IR sensor detected people moving. Okay, looking at the source code, it's kind of messy. So this is the root folder, and I just want to point out some things. We have an index.php, we have an index1.php, we have an indexscript.php, then we have an indexscript part1.js, indexscript part1.php, indexscript part2.js, and indexscript part2.php. And this kind of thing is repeated throughout the code base. And yeah, so you have all the images up here. They are not stored, encrypted, or anything like that. They are just stored in folders. So if you think people with dementia, you would like to keep some security, etc. Now this system ran on their local computer, so it's not so bad because only they had access to it. But we wanted it to be online, so this was impossible to bring online. I mean, absolutely impossible. But, there was no security, no authentication, anything like that. So this is just the structure of the code. I will show you the code because I think it's. I have some slides where what it looks like, but I'll show you the code instead. that was the other code. I do believe I have another editor. Okay. This is index1.php. Actually, I can show you the folder as well, just so you can see. So yeah, there are some files in this folder, making it rather difficult to understand the code just by looking at the folder structure. Wouldn't you agree? Okay. Looking at index1.php. Before I do that, I should look at the file sizes. So let's see, index1 is 346 kilobytes of text. And index.php is 74 kilobytes of text. That is a lot. This index1.php is 9,191 lines long. I will. So it starts with some basic. I mean, it's not so bad up into here. It's not so bad. And then we have some hard-coded things, which is always nice to see. When I was making it impossible to basically bring to an online service. Now it's localhost already there. And then we have very long comments as well. Like this is some test that has been done. Rather than having a separate test class that goes through everything or doing some unit tests, it's been kind of included here. Add fake nodes and so on to test if there's a bug and so on, and that's commented away. Then we have translate date SE. So this, I suppose this does something. So it translates, well, it's an array that translates things, hard-coded. It's also very useful. And then we have some more HTML all of a sudden, because, yeah. We have some nice long spaces, some more HTML. Lots of tables as well. That's also, well, I suppose that's not so bad, I guess. But then we have parent div 5, and then var AA, BB, BBB. And then I think these are nice. Add seconds. And then we rather than using the built-in functions in PHP, we parse the current time and add like seconds and minutes and hours. And then we have some more AA, and then we do it again because reusability, the same thing. And of course we have some more AA and AAA and AAA and some more adding seconds and minutes, because I think there are some slight differences here. I don't actually know, but and yeah, then we have some more long comments, and there are no functions yet, by the way. It's just like added here. So I think we'll get to the functions in a while. Okay, here's the first function, just test, display main. And I've gotten permission from the original author to show this, by the way, as long as I kept him anonymous. Because he also realized that it could have been improved. I think this is the first program, really, so it's, I mean, everyone who starts programming starts off kind of like I'll start without the design and then you add things, and this is a result of starting without the design and then adding things. So I shouldn't like blame him so much. It's the first program, and it worked very well in the end. So I mean, it was the most stable prototype we've tested at the university, which was amazing. But I like these function names: process activity 17. Process activity 5, which is after 17, of course. And then we have process activity 18. I'm not exactly sure what these different names are or what they do, but 5, 17, and 18, they are very important. More comments. We are at line 2000, by the way, now, and I hope you are able to see exactly what's going on in this code already. So you can easily refactor this code afterwards. And we're going to have a small exercise where you're going to do all this in like half an hour. Sorry. Yeah, and now we're into clustering and stuff. I don't think these are actually in any function. So this is just in the root of the PHP because you are allowed to do that. You're allowed to mix functions and like just plain code. This is a very nice in no function at all indentation. If you look at my side here, you see where it starts, and then I can just scroll down to there, and it's very well indented. Yeah, there we go. I think there is like more function 27 and stuff. Process activity 6 down here. Anyways, this goes on for a while. I'll just show you like. And some more PHP, and some more, and some more, and some more. Oh, here's another one, a long one. When you look at the right side here, so it starts here and it goes on for a while down here. I kind of get the feeling that it's a lot of this repeated, and we go on to the end here where we start seeing some HTML again. I think. And here we have the end tags for the HTML file. And here are like parent div 2016. So everything is clear how this works. Good. That's what I wanted to check. PowerPoint. Okay. There we go. So, how do you refactor this? It's easy, right? Okay, so that's why we brought in the intentions level. So looking at all the, well, we already checked at this. There's a lot of hard-coded things, and the language was hard-coded, and so on. Activity 8 main. Well, we have a lot of these as well. SQL queries all over the code, hard-coded and stuff like that. Suddenly, all of it on line 9000, we suddenly have like attributes, the image width and stuff on that, on all the images. Just so a lot of problems. And there was no documentation whatsoever, none. No layers, no, I mean, every file was in the root. Some lack of modularity, a lot of duplication of code. As you could see, there were a lot of like different things. The database login was done in 59 different files and several times in each file. So changing changing password, because the password was hard coded as well. Changing the password on the database required you to change in 59 files. So slightly difficult to refactor, right? But that could happen. I'm just saying it could happen. You could get some code that is really difficult to refactor. So the student, the master student here, he decided to basically do a big bang approach. Like, okay, let's just look at the working application, because it was working very well. So the web application, click around, see what functions there are, and do it all at like in the intentions level. Look at the features. Try to recreate the features, do a new design from scratch, do an architecture, try to find frameworks that did all this. Do it like, in this case, it was do it in big steps. And then once the whole big bang was done, once there was something working, he started doing smaller steps where he improved his own code which was a lot easier then. So it was an iterative process. He used a lot of design patterns in his code, architectural documents, and so on. I have 15 minutes left, okay, or something like 20 maybe. He tried to remove all the duplications and so on. He used Zen framework, which may not be, it was good for this purpose. Well, actually, it was very good for the thesis because he wanted to prove like the whole reusability with adding frameworks and so on. I used Doctrine for object relation mapping. So these were basically two, helpful frameworks for handling authentication and all those things for Zen framework, and for handling like viewing pages. The MVC pattern was better built into the Zen framework. So he went from this structure to this. The reason for the whole module, the kind of lots of folder is the Zen framework. It basically works on that. I would say that this too is rather difficult to understand, but it was at least clustered into different things. So you can find, if I would like to do the whole clustering algorithm, all of that was in here. The whole visual part, the review client, was here. So you have the views, the templates, and all of those. Actually, the views here. We have the templates for a life story, for a person, for a place. Those were all in there. So you can actually go and find them in one location. So it's easier to find them. So here you have, for each of these, you have some, each of these files handle how they access and interpret data from the database and so on. So rather than have it in every place, you have it in separate files to make it a lot easier. So you can change the database if you wanted to, or add things later on. So this objects related database for Doctrine. So here are the views, the layouts. Suddenly we already even have like layouts for the error pages and stuff like that. And here you can set like you can set the places and so on. A little bit easier, and also everything was all the language specific things were stored in a file or using a separate tool that would just create translations for you, and it would remind you when there was a missing translation. So it was very easy to add new translations. So we had very easily just English and Swedish right out of the bat. It was very easy, and then you could add whatever language on top of that. I'm just going to go through this fairly quickly. So we have some controllers. You can add more controllers. So this is MVC. You can add more interpreters for data and so on very easily. So is this better? Well, it's easier to understand, maybe not optimal. It took him about 3 months to do the whole understanding what was going on and trying to reverse engineer everything or recreate everything. But he did it like according to all the principles and tried to learn about the whole software engineering part as well while doing this, to describe it in his thesis as a software engineering thesis. But it's very hard to prove that it's better, right? So we can look at a number of metrics. We can look at code complexities. It's difficult to maintain, greater complexity. Here's where the whole metrics comes in, right? We talked about this modifiability metrics or quality attribute. And we have some metrics. How do we measure whether we have delivered something that's better? So we could see how long does it take to make a change. That would be like some measurement of this. We could do lines of code. And then we should probably separate between the hotspots and the code frozen spots, right? Because the lines of code in the hotspots, it's a lot less, but the whole project as a whole is actually more code. And we can show that here. So the old code, if you just look at the hotspots, the old program had actually XML files, some 7,500 or so, SQL. There's a lot of lines of code. Actually, it should be more here, I guess. No, it's okay. It's 48,000. So it's not 9. It's 48,000 lines of code for PHP in this case. While the new one had in the hotspot area like 6,000. total, which is less than only the index file, right? But if you look at with the framework, the new version actually has like some 27,000. But this is the frozen spot. You don't need to look at that code. So just looking at the code you actually have to modify, it's a lot less. Yes. So, or is it actually, no, it's 270,000. So it's a lot of code in the Zen framework, right? Because it's a big framework that handles lots of things, which means that certain parts might be slower or something. I think it's quite fairly well optimized though. Now, the funny thing is we actually wanted to put this in our company because it was, the healthcare people really liked this. So we looked at, or our developer looked at the updated code, this Send2 framework code and so on, and thought, this is a little bit too difficult to understand for me. Like using the Send, I have to learn about the Send framework first of all. And he didn't want to do that. So what he did, he recreated the entire thing in Django in 2 weeks. And basically has the same functionality, because in Django you get a lot of the administration for free, and Python, and So yeah, you can do this in several steps, of course. But I think it's still, I really like this master thesis that my student generated, because it really showed like the whole why re-engineering, what do you actually think about, and so on. Okay. Any questions so far? I hope this has been eye-opening for you guys. Okay, good. So for engineering, don't do everything from scratch. If there are frameworks or middlewares or whatever, if there are things you can reuse, try to do that. Use design patterns; they are there to help you along, and that's why it's also good for you to have some basic understanding and at least have seen them. So whenever you see a problem, you go, oh, it wasn't there a design pattern, I'll go look it up online. There are lots of text online, examples how to use things. And yeah, there are 3 basic steps: reverse engineering, restructuring, refactoring, and then forward engineering. But if you feel limited by these, just make up your own things. In this case, the student here invented the intentions level kind of thing, where it was just too difficult to understand the code. It was impossible to refactor. Yeah, and think about the whole metrics thing. Try to think about using modularized things, high cohesion, low coupling, and all those things. Build upon other shoulders. Don't reinvent the wheel. And comment your thing, document things, create, along the way, keep things updated. Because having a difficult structure with no documentation is a nightmare. Having some documentation, in this case, had the original developer just kept the design specification in the folder, it would have been much easier to understand the intentions of it, even if the code was not reusable. But you can at least use the same requirements, right? Okay, and try to conserve the familiarity. Try to, the whole classification thing. Okay, I think we will end it like that, unless you have any questions. Okay, on Monday we have Försäkringskassan here, the National Insurance Agency, and they will talk about system testing and show you some live coding as well, and so on. So have a good weekend, and thank you.